Okay, so welcome back. In this video, we are going to talk about vectors. So we are still looking at vectors. So we are going to solve some questions under vectors. I believe you managed to watch the videos where we introduced the vectors, where we talked about how to find the direction, where we talked about how to know that the angle falls in the first quadrant, second quadrant, third quadrant, and fourth quadrant. And we also talked about the terms which are used in vectors, where we talked about the north of east, north of west, and then where we also talked about when a vector is going in southwest, then when it's going east, west, south, um, and north. Okay, so I believe you managed to watch the videos. So this time around, we are going to solve some practice questions. So let's begin. Here is the first question for us, which is saying a particle undergoes three successive displacement in a plane as follows: 4 meters southwest, 5 meters east, 6 meters in a direction of 60 degrees north of east. Choose the y-axis pointing north and the x-axis pointing east and find part 1 the component of each displacement, part 2 the component of the resultant displacement, part 3 the magnitude and direction of the resultant displacement, part 4 graphically show the appropriate displacement of the particle. Okay, so it is very simple and straightforward. First of all, it is very important for us to come up with a free body diagram. A free body diagram is going to help us to find it's going to help us to find the angles of the vectors. Okay, so here is the free body diagram. So here is going to be our free body diagram. We have been told that the first vector is 4 meters, which is southwest. And remember, we talked about these. These are the terms which are being used in vectors. So when we have to say southwest, the angle is in between south and west. Okay? Meaning that this angle is supposed to be in between south and west. So here is in between south and west. Okay? So that is between southwest. So this is our vector. Now, I want just to put, we can just say this is vector A, it's okay. Okay, which is 4 meters. Now, remember we talked about how to find the angles. So we know that when the angle, when they say is in between south and west, meaning that the angle here is 45, here is 45. So we know that in vectors, to get the angle, we are supposed to get the angle from positive x-axis. So this is positive y, this is positive x. So from positive x-axis until it touches the vector. So this is 45 and this is 90. Okay, so if this is 90, meaning that we can say 90 plus 45, which is going to give us what? It's going to give us 90 plus 45. It's going to give us 135, meaning that the angle for vector A is 135. Okay, so it's okay. I can just put this 145 here. And then we have another point which is saying 5 meters east. So we know that whenever we are talking about east, it's in this line and the angle is 0. This line here. Okay, so that will be our vector. So let's say this is vector B, which is 5 meters. Okay, and the angle is going to be 0 because it is in the line of x-axis. Then we also have 6 meters in a direction of 60 degrees north of east. North of east, remember we talked about this. The angle is near east than north. Okay, so this 60 degrees is near east than north. That is what it means. So what we're going to do there is um, we're going to put our vector here. This is going to be our vector. Let me use. So this is going to be our vector. So that vector is 60. Let's call this vector as vector C. And we say that this is 5 meters. Oh, it's 6 meters, sorry. It is 6 meters. Okay, so if this is 6 meters, and then now we know that the angle there is 60 degrees, and that will be the angle which we are going to use. Now these are the only vectors we have. Now the first question is saying we need to find the component of each vector. So it's just a matter of us resolving each vector into x and y components. So we have vector A, we're going to have A, x is going to be equal to, we know that for vector A, the angle is going to come from this point all the way to that point. So it's going to be 90 plus 45, which is going to be 135. Okay, so we're going to have vector A cos theta. Whenever we're resolving any vector into x component, is that vector cos the angle. So AX is going to be equal to, the A is 4, cos the theta is 135. So our AX is going to be equal to 4, we have 4 cos 135. I'm getting negative 3.98 meters. So I can just put it here. I put this here to create space. Okay, and then I'll go to AY. So AY is going to be A sine the angle. AY is going to be, the A is 4, sine theta, theta is 135. So my AY is going to be 4 sine 135, which is 0.353 meters. So our AY is 0.353. We are done with the component of A. Let's go to B. Bx is going to be B cos theta. So whenever we're trying to resolve a vector into x component, this is the formula. That vector which we have been given cos the theta. So we are going to say that Bx is going to be, B is 5 cos 0, the angle is 0. So our Bx is going to be 5, because if we do 5 cos 0, it's going to give us 5. So I can put it here and say Bx is going to be 5. Okay, then let's go ahead and find the y component of vector B. So it's going to be By, it's going to be B sine theta. By is going to be, B is 5 sine 0. So this is going to give us 0. So By is going to be 0. Let's now go to the vector C. So C, we are going to have Cx. We have Cx is going to be C cos x. Then we are going to have C is 6 cos 60 degrees. So Cx is going to be, what is 6 cos 60? I'm getting negative 7.514, negative 7.5, or negative 5, not 7, negative 5. I'm getting negative 5.714. So I can just put here to say Cx is going to be equal to negative 7.7, negative 5.714. Now let's go ahead and find the y component of vector C. So it's going to be Cy, it's going to be C sine theta. So C is 6 sine 60. Cy is going to be 6 sine 60. So I'm getting negative 1.829. Now this is part A is saying find the component of each displacement. So these are the components which you have come up with. Okay, these are the components of each displacement. Now the next question is saying the component of the resultant vector. So the resultant vector is the addition of all. So we are going to add the x components alone as well as the y components alone. Okay, meaning that the resultant vector is going to be the resultant vector. Now the x component is going to be ax plus bx plus cx. So we are going to say that ax is 0.353 plus bx is 5, then plus cx is negative 5.714. So now let's go ahead and find the x component of the resultant. So it's going to be 0.353 plus 5 minus 5.714. Okay, so I'm getting negative 0.361 meters. So this is the x component of the resultant. Let me just put it here. Negative 0.361. That is the x component of the resultant. Now let's find the y component of the resultant. Now to find the y component of the resultant, we are going to say that our ry is going to be ay plus by plus cy. So our ay is negative 3.98, okay, and then plus our by is 0, plus our cy is negative 1.829. Let's go ahead and find the y component. So it's going to be negative 3.98 plus 0 plus, or let me just say minus 1.829. Okay, so I'm getting the y component as negative 11. Negative. This is not supposed to be 11. It's not possible, meaning I punched wrong values. So it's supposed to be negative 3.98 plus 0 plus minus 1.829. Yeah, it's giving me negative 5.809. Negative 5.809. That is the y component of the resultant. Now we can get rid of these ones. This is the part 4, the answer for part 1. We no longer need this. Now we can just put these guys here to say our rx is negative 0.361 meters, then our ry is negative 5.809 meters. Now what we're going to do now is we go to part C, which is part 3, which is saying find the magnitude and direction of the resultant displacement. So we know that to find the magnitude, we use this, the square root of the rx squared plus the ry squared. So the magnitude is going to be equal to, we are going to get the rx is negative, so we're going to put them in brackets, negative 0.361 plus negative 5.809 squared. So let's see the answer which we're going to get. Now the reason why I'm putting this is just because it's a vector. The moment when I just leave it like this is a scalar. So a vector, you can represent it using modulus or just putting an arrow on top. Okay, so we have negative 0.361. We square it plus, you can just ignore the negative because if we square the negative, we're going to get a positive. So we're going to have 5.809. I square it. Now I get the square root. So I'm getting the resultant as 5.829 2 meters. So that is the magnitude. Now to find the direction, we know that the direction is given by theta tan inverse the ry divided by the rx. But remember, before finding the angle, we need to know to say this vector falls in first quadrant, second quadrant, third quadrant, or fourth quadrant. How do we know? We know using the signs. So here we can see that the rx, the x component is negative, the y component is negative. So we know that this is negative y, so meaning the angle has to fall in, this is negative, has to fall in this quadrant. Now when the angle falls in the third quadrant, what we do is we say 180 plus the theta which we're going to find here. And we managed to, we talked about this when we were talking about how to find the direction. Okay, so I hope you managed to watch the video. So we have 5.89 meters. That is the size, which is the magnitude. So we want to find the direction. So let's plug in the values. So we have theta tan inverse. The rx, the ry is, we just ignore the negative. Don't include the negative when plugging in the values. Just ignore the negative. Okay, so we have this. So we're going to say shift, then tan inverse. Okay, then you open the brackets, you say 5.089, everything divided by 0.361. You close the brackets. So I'm getting 1.499, which is the same as 1 point, which is just the same as 1.5. So the theta is 1.5 degrees. Now, after finding this, the final answer is going to be, we know that it falls in the third quadrant. So in third quadrant, we say 180 degrees plus the theta. So we're going to say 180 plus 1.5. Okay. Which is going to give us 181 point. So the angle is going to be 181.5 degrees. So that is the direction. Then the last part is saying graphically show the appropriate displacement of the particle. Now, I think we talked about sketching, which is the same as graphing. So we can graph this using sketching. So we know that we can just get it from here. We say here is going to be my starting point, or I can just get rid of this. I get rid of everything here. Now I need to graph it. So graphing, I know that I'm going to start from, let me start from this point. I can just have a xy plane here. So this is going to be my starting point. So I know that this is my north, south, east, west. The first vector is saying 4 meters southwest. Okay, so southwest meaning the angle is in between in between south and west. So we can say that this is going to be, so it's 4 meters. So 4 meters, we have 4 meters, 5 meters, and 6 meters. So 4 meters is going to be shorter than 5 meters. At the same time, 5 meters is going to be shorter than 6. So you're going to have this. So we can say that this is going to be the first vector which we have. That is the first vector. So that vector is, we are going to say that is vector A. Let's just put it there, vector A, which is 4 meters. Okay, so if you want, you can even show that the angle from this point all the way to this point is going to be 135. No problem. So you have reached the destination. Now you go to vector, the next vector. So the next vector is 5, which is going east. So you start from this point. From this point, you can even draw an xy plane. Just a dotted one. You know that this line is east. So we're going to start from there and say this point is going to be our east. Then we go there. So this is going to be a bit longer than vector A. So this has to be a bit longer than vector A. So we are going to put that one as vector B. So we're going to say this is B, which is 5 meters. We have reached at our destination. Let's now have our xy plane again. We go to vector C, which is, they're saying that it is 6 meters in the direction of 60 north of east. The angle is near east than north. So meaning that this is going to be like this. Okay? So we're going to have this. We have this. So this is supposed to be a bit longer than vector A and B. So I'm going to put it there and then I put it somewhere there. Just put it there. Okay? That is going to be my vector C, which is 6 meters. So from this point, I can say that this point is going to be 60 degrees. So that would be now, this is the representation of sketching. Now, to connect the line from the original position all the way to the last one, that would be now the resultant. So the resultant is going to start from here until it goes there. The last part. Okay? Although this one was supposed to be like this. Let's just do this. We just change just something just a bit. We say that this is I can just put it here to say it's supposed to be in this direction because it's supposed to be near east than west, than north, sorry. Okay, so that is our vector. So C is 6 meters. Now the displacement is going to be from this line here all the way until we connect to the last one. That will be our resultant. So this is our resultant. And we found that the resultant was 5 point something. I've just forgotten the figure which we got. Yeah, but it was 5 point. Yeah. So that is the resultant. So now this is what we need to understand. Okay.